In this section, we're going to talk about matrix operations. But I just want to make sure I start off with what is a matrix before we get too far, because some people may not remember. So the key word here, matrix, it's simple. It's just a rectangular arrangement of numbers. Now, it can be used in many different ways and take on many different representations, but right now, all we need to understand is it's just I have data and I want to put it in a matrix. I want to put it in a rectangle. So you could think of it, if you're familiar with Excel, it's very similar to putting things in an Excel spreadsheet. It's just a ordering. So to demonstrate, what we always do for a matrix is we'll always put little brackets. This is what shows my numbers, my matrix, my single matrix lives in here. Now, you'll go ahead and fill that in with numbers that make sense for whatever the context is that you're working with. So for example, this matrix has 2 rows. We always start from the top down. We say this would be our first row, this would be our second row. So row 1, row 2. Now, then the next thing we're going to do is say this matrix has columns as well. Whoops, let's not do that in blue highlighter. This has column 1, column 2, and column 3. And columns are vertical in nature. So we would be therefore talking about something that maybe something like this. Maybe we have 2 McDonald's franchises that we own. Okay. If you don't like McDonald's, fill in your favorite fast food here. My kids are just addicted to chicken nuggets. All right, so I have 2 McDonald's franchises. This is my McDonald's number 1. This is my McDonald's number 2. Now, and maybe what we're talking about is different things that we need to order. So like, for example, this would be cases of cups. Then here we have cases of, I don't know, nuggets, chicken nuggets for my kiddos. And then last but not least, this third column, maybe that represents, I don't know, how about forks? So what would this mean? Well, it's a lot like the game of Battleship. My row and my column intersect. So this number 1 here is for my McDonald's franchise number 1, I need 1 case of cups. For my McDonald's franchise number 2, I need 2 cases of cups. So you just kind of look at the overlap and there you go. So that's it. That's all there is to matrices. Now we can use them to describe other things as well. Like, so for example, equations, which is what we'll do in 4.3. We're going to take equations with variables and put them in here. But it's really just a shorthand. It's a way of saying, so instead of me having to write out 1 case of cups, 2 case of cups, 0 nuggets, 1 nuggets, 2. Now you can look at the grid and figure it out. Okay. Now, before we can move on, though, there is some notation I want to talk about. So, for example, the first thing we need to do is we need to name our matrix. So, if I had a matrix, maybe that this was talking about profits, and in my different franchises, one of them brought in $1,000, and another one brought in $7,000, another one lost $4, or whatever it may be. However you want to talk about your money or your profits. We'd have something that looks like this. Well, it would kind of make sense then to name this thing the P matrix for profits. Now, notice we always use, for a matrix, we always use a capital P or a capital letter. Now, my handwriting is so bad, I want to make sure I'm going to actually change that to an A, just because capital A's are nice and clean for me. Now, so a capital letter is a matrix. Okay, and that's it. That's how you name matrices. So the next thing we want to talk about is elements of a matrix. An element is just a single value in a matrix. That's it. So, for example, the number here, this number 7, is a element. It's an element of the matrix A. But I need a way to talk about it because I can't just draw arrows to everything. That would be a little inconvenient. So what we do is we're going to talk about rows and columns. So in this matrix, this row here is row 1, and it is living in column 2. So because remember, we always go like we're reading. We start from the top, so row 1's at the top, row 2 goes next, and then if we had another one, row 3, then row 4. And then we always start on the left, so that's column 1, then column 2, then column 3. So this element lives in row 1, column 2. So therefore, when we describe it, we're going to write it kind of like this. But that would be confusing if there was just a number 21 floating on the page. You'd be like, what is that? So what we do is we're also going to borrow the letter. But instead of writing a capital A, what they've decided to do is write a lowercase a to show it's from my matrix A, but it's not talking about the entire matrix. We're talking about a single element of it. So this means from matrix A, row 2, column 1. It always goes in that order. It always goes RC. You can remember that however you want. RC Cola, remote control cars, whatever you want, but it's RC. Now, if your matrix was huge, because sometimes in the real world your table's going to have 10,000 different elements, and it might be confusing if it was coming out of like row 17 and column 54, and I wrote it as A1754. How would you know? Is that really row 1, column 754? I don't know. So what we do is we use commas to separate our numbers to give it a little more clarity. The good news in this class, we're not really going to run into that, but I just wanted to mention that because sometimes students that's the first thing that pops in their head when I start talking about this. So there you go. In this class, it's kind of nice, almost always single digit rows and columns, so it'll be kind of clear when you see 21, it's clearly row 2, column 1, because there's no other options. Last we need to talk about is dimensions. What a dimension is just the size. You could think of it as kind of like the size of the matrix. Okay, and again, we're just talking about rows and columns, size, and so rows by columns. So the matrix from up here had 2 rows and 3 columns. So our dimension would be 2 by 3. That's it. There's not much more to that. All right, in the next video, we will go on to some operations.